here we are looking at some segment lengths in a circle, and these maybe seem a little wordy, but once you kind of get the hang of what segments you're putting where, they're not too bad. For this first one, it says if you have segments of chords, if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So you're going to look at like one chord and multiply its two parts together. So in this case, AB times the length of BC is going to equal, for this chord, those two pieces multiplied together. EB times BD. So looking at this example, what I could do is I could just look at each chord. So this chord has these two parts. I'm going to multiply those two parts together and set that equal to these two parts multiplied together. This one's not too bad algebraically. We just have 6x equal to 60, or x equals 10. For this next one, this is a little more work, algebraically speaking, because we have to do distributive property, and we're going to end up with some like x squareds when we're multiplying these together. So I need to multiply x times the quantity, x plus 12, and that's going to be equal to these two parts multiplied together. And just like in the last section, I need to think FOIL method for this, or distributive property also. So when I distribute here, I have x squared plus 12x, and then for this one, I have x squared plus 2x, and then distribute that 6 to each of those other terms. I have 6x plus 12. And if you need some extra assistance with this algebra, please let me know. I know you guys spent quite a while working on it last year, but that's been a little while, so if it seems confusing, just let me know and I can work a little more one-on-one with you. I'm going to subtract 8x from each side. It actually works out a lot nicer than maybe it looked like at the beginning, because again, those x squareds are canceling out. So in this one, you would get x to be equal to 3. For these next two examples, we're going to use that information about the chords to find different parts of the circle. So it says here under astrodome, the highest point or apex of the astrodome is 208 feet high. So we have the astrodome, the highest part is 208 feet, and it says the diameter of the circle containing the arc is 710 feet. We're trying to find how long this stadium is from one end to the other. So we're trying to find this distance here. If I continue to make that circle, it says that the diameter, so this whole way across, would be 710 feet. I could then use that, I know this is supposed to just kind of be one line, I could use that to see what this part's going to be. This part here is going to be 502 feet because the whole diameter is 710, and I'm just going to take that part away. Since I want to find the whole way across, I have to split that up into two, and both of these are going to be exactly the same distance because the apex, I know I kind of have this drawn off to the side, but that apex would be right in the middle. So when I set this up, I'm going to write that this is x squared, because I have x times x, equal to 208 times 502. So I'll go over to my calculator. 208 times 502 is this number here. I'm not even going to bother to write that down. I'm just going to take the square root of that number, and this is how long this part is. So if this part is 323.1 feet, or you can just say about 323, the whole way across at this point would be 646 feet, because both of those are the same, because that apex is right in the middle. Here where it says biology, it says biologists often examine organisms under microscopes. The circle represents the field of view under the microscope with a diameter of 2 millimeters. So the diameter of this circle is 2 millimeters. Determine the length of the organism if it's located 0.25 millimeters from the bottom of the field of view. Round to the nearest hundredth. So I'm just finding this part again. This is a lot like this one, except the circle's a little nicer than the one I drew. So this portion of this chord is going to be 1.75. Both of those are going to be the same. So I have x times x equals 0.25 times 1.75. When I set this up, I get x squared. Let's go over here. 0.25 times 1.75, and then I'm going to take the square root of that. That is going to be about 0.66, and that'll be millimeters. I don't need to double it here because I'm not finding the whole way across. I'm just finding the length of the organism, and that organism is right there. I chunked these next two theorems together because they essentially end up having the same formula when the segments intersect outside of the circle. The book writes them differently, but I kind of think about them together because they're kind of one and the same. So I'll read through it and then we'll explain what that would look like on this picture and then do some examples. So when you have two secants intersecting on the outside of the circle, the product, so when you multiply together, of the measures of one secant segment, so the whole thing, and its eternal secant segment, so that's just the part outside, is equal to the product of the other secant and its external secant. So if you remember, it's the whole thing, AC, times the part outside, would equal the whole thing here, AE, times the part outside. And that's how I think about it. It's the whole thing times the part outside. And it's just going to equal that same thing for the other secant. So in this case, when I'm looking at this tangent, the whole thing and the part outside are one and the same. So what it says is, it says if a tangent and a secant intersect on the outside of a circle, the square of the measure of the tangent. So if you were thinking about like the whole thing times the part outside, they're the exact same part. And when you multiply something by itself twice, you just square it, equals the product of the measures of the secant, so the whole thing, and its external secant segment. So that would be JL. This is what I remember. So looking at this one, this is two secants. If you want to write out what the whole thing is, that might be helpful. The whole part here is 9, and the whole part here is x plus 9. So just remember, it's the whole thing times the part outside equals the whole thing times the part outside. And then you're going to go through and solve that for x. Go ahead and subtract 36 from each side. I have a little bit of a problem here that I cannot just solve this one using the same steps as I normally would algebraically if this wouldn't be x squared and 9x. There are a few different ways you learned how to do this in algebra. There was factoring, there was completing the square, and the quadratic formula. If you do not remember those from algebra last year, make sure we talk about this. But instead of going into like all of the methods, I thought what I would do is just offer you one method, the quadratic formula. If you remember how to factor, or if you want me to explain that to you quick separately, I'd be more than welcome to help you with that. That would be the easier method for this one here. But because that doesn't work all of the time, I'm just going to go with like one way. When you get to Algebra 2, you'll do more work with all of these things. So the quadratic formula says x equals negative b plus or minus square root b squared minus 4ac all over 2a. And I can't help but kind of sing that as a song when I say it. If you had me for algebra, you probably remember that song. So we have these three terms here when this is in standard form. A is 1, B is 9, and C is negative 36. I'm just going to take those numbers and plug this into this formula. So the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So I'm going to go through and just simplify this. 9 squared is 81. When I multiply those together, let's see, 72, 144 over 2. Negative 9 plus or minus the square root of 225 over 2. Negative 9 plus or minus 15 over 2. And you're actually going to end up with two answers here, and then we'll talk about that. So negative 9 plus 15 is 6, and 6 divided by 2 is 3. Negative 9 minus 15 is negative 24. Divided by 2 is negative 12. So algebraically speaking, both of these are correct solutions for this equation. But when we're thinking about how long this segment has to be, only the one makes sense. This segment cannot be negative 12 units long. This segment would have to be 3. This next one's not quite so bad because that x is on the inside here. When I'm looking at this whole segment, that's going to be 19. This whole segment is x plus 6. When I set this up, I have the whole thing times the part outside equal to the whole thing times the part outside. So let's see, 19 times 7 is 133 equals 6x plus 36. When I subtract 36 from each side, I get 97 equal to 6x. And then dividing by 6, I get 16 and 1/6. If you change that to a decimal, that's fine. For this last example, here I have a tangent. This tangent, I'm just going to square it, and that's going to equal the entire segment, which is 2x plus 2 times the part outside, which is x. 144 equals 2x squared plus 2x. I can't solve this the same way I do here because I have the x squared and the x. So I'm going to get this in standard form, and then I can use quadratic formula again. So in this case, for the quadratic formula, a is 2, b is 2, and c is negative 144. So I'll write that out if you need that. And I'm plugging them in to this formula. So the opposite of b would be negative 2 plus or minus square root b squared minus 4ac all over 2a. And I know this one's not going to work out quite as nice, so I'm going to go ahead and grab a calculator. and try to find like a clean spot to put that. Okay, so for this one here, I have -2 plus or minus. I know that this is going to be 4, and I have the square root. It was kind of messing up a minute ago when I was trying it, so I'm going to type it in this part first. And I know a negative times a negative is a positive, so I'm just going to type in 4 times 2 times 144. And I get this number here, and I'm going to have to add the 4 to that. So the thing underneath the square root sign is 1,156. What I'm going to do then is take the square root of that. If I had a scientific calculator here, I would show you better with that. I have -2 plus or minus 34 over 4. -2 plus 34 is 32 divided by 4. That is 8. And then when I subtract, I have -2 minus 34 is -36, and when I divide that by 2, that's -9. So again, that one doesn't make sense. The only answer here that makes sense is 8. Sometimes they won't work out to be like a perfect square root, and then you're going to have some decimals you have to deal with. It said if that were the case here, they wanted us to round to the 10th. So I look forward to helping you guys with this in class, and I hope this is very helpful.